Hello students. The diagram shows a water container in the shape of a triangular prism. The depth of the water in the container is h, which they have shown. The container has got the length of 5, and the water in the container forms a prism with a uniform cross-section that's an equilateral triangle of side x. So that literally means if I draw that cross-section over here, so it should look like something like this. This is x, this is x, this is x. So if I'm drawing h from here, and so this angle should be 30 degrees. So yeah, because it's an equilateral triangle, so each angle should be 60 degrees. So that's got divided into 2, so that's 30. So if we first apply the Pythagoras theorem, so the height h that I get from here, since this becomes, this particular length is x by 2. So we got height h as equals to root under of x squared minus x by 2 whole square. So that's the height form that we got. And we can also write from this triangle that cos of 30 degrees is equals to h over x. So these are the two relations that we got from the triangle that we have drawn over here. So now the area of this triangle should be given as half into x into h. That means half the perpendicular distance into height into the base. And the area is this is also written as half of x squared sine of 60, which is like the multiplication of the sides and the angle included between them. So if we're using this formula, so the value of x that we got, or the relation between x and h that we got, x equals to 2h over root 3. So that's the relation that we got, because half gets cancelled and we simply get x cancelled, and the value of sine 60 degrees root 3 by 2. So we got this value. Now, if I'm now writing the volume of the part given, so volume is always defined as area into length. So the value of x that we got is 2h over root 3. So that means we can use the formula half x squared. So x squared is 2h over root 3 whole square into sine 60. So that's the area that we got, and that's multiplied by length, so we get the volume. So that means the volume that we are now getting should be equal to half into, so that becomes 4h squared over 3. The value of sine 60 is root 3 by 2, and that's into 5. So that means this 4 goes out, and the volume that we got is equals to 5 root 3 h squared by 3, and that's the expression of the volume that we are looking for in one part A. So now, if we go by the marking scheme of this, so getting this equation correct, you get 1 mark for this. Writing down the relation correctly between x and h, so you get 1 mark for this. Writing down this formula correctly, you get a mark for this and a mark for the final answer. So this is how the marking scheme for 9A works. Now, moving on to the second part of the question, if I move on to the 9B, so that water is pumped into the container at the rate of 0.5 meter cube per minute. So that's the rate of change of volume which they have given. And that's find the rate at which the depth of water is increasing when the depth of water is 0.1 meter. So we first have to find the correct derivative of dv over dh. That means we are differentiating this. So we got it as 5 root 3 over 3, and the derivative of h squared will be 2h. So we got it as 10 root 3 over 3 into h. So that's the value of dv by dh that we got. So they have asked the rate at which the height changes. That means dh by dt, and that can clearly be written as dv over dt into dh over dv. So now the values that they have given, dv over dt is the rate of change of volume, which is 0.3, and the water is changing when the height is 0.1. So if now I'm finding dh over dt, so this value is 0.5, and this is dv over dh. So that means that's just the reciprocal. So we can say it's divided by 10 root 3 over 3, and the value of height we placed as 0.1, which is given in the question. So the rate at which it changes is 0.866 meters per minute. So that's how the height of the water in the prism is changing. Now, if I go by the marking scheme, so making this derivative correct, you get 1 mark for this. Writing this step correct, you get another one for this. Calculation, putting the values, you get 1 mark for this and 1 mark for the finals. Thank you, students.